A solution to the system of equations below. I may not do all of these problems just for the purpose of time today. How do we do this? This is not an RREF problem, and here's how you know. Please listen, this is not an RREF problem because I don't have two linears. Does everybody see where I have a quadratic here? Quadratic and a quadratic. That means the highest exponent is a 2. When they're both not linear, that means we can't do RREF. Instead, we're going to find out where do they intersect. Go up to y equals, and actually I'm going to start by clearing the RAM, and I'm going to go up to 2x squared, subtract 12x plus 10, and then 2x subtract 10, and I'm going to find out where they intersect. This particular problem intersects in two places, and so I'm going to go second trace intersect, and I'm going to use the cursor to get close. First curve just means first equation you plugged in. Press enter will be the second equation you plugged in, and then over the top of where they do intersect. So 2, -6 is one intersection point, 2, -6. The second intersection point, second trace intersect. Okay, we have 1, 2, second curve, over the top where they intersect, and 5, 0 is the next one. Here's 2 more problems you're welcome to practice. Go on to number 4. Given the equations below, what is one solution to the system? Does that mean there is only one? No, they're just saying, give me only one answer. So let's go back. I'm going to start it again. That's my preference, is to clear the RAM. I'll go up and again do x squared, subtract 8x plus 4, and -x subtract 6, and graph it. Now I can see that it'd be nice if I could move this down further so I can really see where they intersect. So I'm going to go to Windows and I'm going to move down the Y. Remember on your test tomorrow, I can't help you with the calculator. I cannot help you with the calculator on the AZMerit. So second trace intersect, and I'm coming down. So one answer is 2, -8. Now, it's very possible that you put in 2, -8, and they would consider it correct. And it's possible that right now your elbow partner would put in instead an answer of 5, -11, and you both would be correct because it says to state only one solution. Thumbs up or thumbs down if you're understanding the concept. Okay, we're going to move on to the next one.
It's all on the computer, right? It's all...
Yep, it's all on the computer. So the next one is, given the equations below, what is one value where they're equal? Okay, look up here. We want to know one value of x. So again, it's kind of like the problem above where we're only going to give one answer, one value of x. I don't want x and y. I only want an x answer. One value of x where the two are equal. So I want to know, where do these intersect? So same thing right now. I'm going to do second plus 712 up to y equals -x squared, subtract 9, and x subtract 11. Okay, so I can see it's way down here. If I go to Windows and I move this down, I'm going to move it down to -27. Better idea of where these intersect. And I can see 2 intersection points. Do I need to write them both down? Only one. Second trace intersect. So one answer that is acceptable is x equals 1. Another answer that is acceptable is an answer of x equals -2. Either answer is acceptable. They're not looking for the y answers. So be very careful if this is one of those fill in the blanks that you don't put the y answer as well. Okay, turn to the next page. So for this particular problem, they're asking you to simplify the expression below. So remember that you can't take the square root of a negative. So 2 times, this comes out front and it becomes an I. So 2i times the square root of 49 plus the square root of 25 minus 10i. Here's what I worry about. Square root of 49 is 7. 7 times 2 is 14. I worry that you are going to write your final answer incorrectly, but you know how to do it. Here's the thing. Underline the word standard form. Standard form means the real portion followed by the imaginary. So of these three, the real is 5, and when I combine the imaginaries, I end up with a positive 4i. Real quickly, again, you can't take the square root of a negative. 3 times 3 is 9, and this is plus 9i. And lastly, I do want to go over 1. What is I squared equal to, just so you know? I squared equals negative 1. Write that down if you don't know that. I squared equals negative 1. Up here, square root of 100 is 10, so I have 10i minus 10. When I write that correctly, it's negative 10 plus 10i. Remember that I squared equals negative 1. Going down to number 9. Down to number 9. First thing I'm going to do is subtract 6 to both sides. After subtracting 6, I get 108 equals negative 3, x minus 2 quantity squared. Divide by negative 3. Can you please do the math for me? What's 108 divided by negative 3? Nobody? Okay. Take the square root. Can you take the square root of a negative? So this comes out here. I got to do something that comes out front. So I have plus or minus because there's two original answers, plus or minus 6i. Then I add 2 to the opposite side, and I get 2 plus or minus 6i. That's the correct answer for number 9. Doing number 10 a little bit quicker. First, I'm going to subtract to get 2x squared equals negative 50. Divide by negative 2, I get x squared equals negative 25. You can't take the square root of a negative. Remember, you're going to have two answers, plus or minus 5i. Last one is add 19 to both sides. Negative 4x squared equals 80. Divide by negative 4. X squared equals negative 20. Now this is the careful one here. Yes, you're going to have two answers. That is true. But 20 breaks into 4 times 5. So this is going to be plus or minus 2i radical 5. Okay, go down below to number 12. Grab your calculator, please. Do second plus 712. I'm trying to go as fast as possible for the purpose of time. Go up to y equals, and we're going to type this in. 2x squared plus 3x. Actually, you're welcome just to watch me. You're welcome just to watch me plug it in. What does this answer tell us? It tells us that the two answers we have are both going to be imaginary because it never crosses the x-axis. Did everybody hear that? So when it's imaginary, we have to plug it into the quadratic formula every single time. So I'd plug in 2, 3, and 7, and I reduce it. I'm going to let you do that on your own later on. Okay, let's look at the next one. So this one is 2x squared plus 9x minus 18. Okay, how many answers does this one have? This one has 2 reals. Now, by the way, I can cheat here. I think 1, 2, 3, 4, 5, 6. I think 6, negative 6 is one of the answers. Let's check. Second, trace, and I want to know the value at negative 6. Hey, negative 6 is one of the answers. You may be asking, do you have to show work? AZMerit's not looking for your work. And what's the other way? Keep your eyes open, Logan. The other way is to get this answer by going second, trace. It's not an exact answer, it looks like, so I'm going to find the 0. If we'd happen to get an ugly decimal, then I would have to use the quadratic formula. And I'm following it, okay, and it's, here's the cursor. There's my left bound. Right bound means above, and here's my guess. The other answer is a nice answer of 1.5. You are welcome to always, always, always use the quadratic formula to get both answers. Okay, we're going to skip ahead at this time. Please go to the next page. Okay, your next page, determine the number and the type of solutions. Okay, you're going to just watch me do it for the purpose of time. I go up to y equals, and I type in x squared plus 4x plus 7. How many times does it cross the x-axis? So of these two answers, it never crosses the x-axis, 0 and 2. Okay, I get to just change this slightly to be a subtract and a subtract again. How many times does this cross the x-axis? That tells you the number of reals. Crosses twice, 2, and none. These have to add up to that exponent. Okay, the last one, before I move on, is parentheses, x squared, subtract 4x plus 7, and I graph. How many times does it cross? 0. Never crosses. 0 reals. Too complex. Thumbs up, thumbs down if you understand the concept. Okay, going to this one. With your partner number 21, you have 20 seconds to get an answer. 20, 19, 18, 17. Celeste, can you come grab this? 16, 15. I squared is -1. So this is -3 plus 12i minus 5. Combine the reals to get -8 plus 12i. -8 plus 12i. Okay, number 22. Read the question to yourself and do not do it, but come up with a plan. What would you do with your partner if this was an AZMerit question? You have 20 seconds to read the question and come up with a plan, but don't do it. Go. 1, 2. Don't do it. Come up with a plan. Okay, Abara, tell me your plan. What would you do? Please listen, because you may have a different plan. Go ahead, Abara. Okay, so he tells me to plug it in, so hold on. Okay, plug them in one by one. So x squared plus 3x minus 12. Well, what do you do once you've plugged it in? Okay, well, what does the solution look like? When it touches the x-axis, how many solutions does this have? So, and we're looking at least one real. So what does that mean? One or more. Does this have one or more real solutions? And I circle. You go all the way down, checking each one to find out which ones have one or more. Thumbs up or thumbs down if you understand the concept. Okay, let's go down to the next one. What is the exact solution? So first I'm going to graph it to see if I can save myself time. X squared plus 7x plus 17. I graph it. Now if there is no real solutions, that means I must use what formula? Must use quadratic. I'm not going to take time to do it, but -b plus or minus b squared minus 4ac all over 2a. Good to go? All right. You plug it in and get your answer. Okay, flip to the back. As a quick reminder, I don't have time to go over all of these. I just want you to write down, I want you to write this down. This means we are shifting everything down 5 from the original function. This means we're shifting everything to the left 5 units. This means we are stretching vertically by a factor of 5. This is the confusion. If you look at D and you look at F, that's a confusion. If it's outside, we are reflecting across the x-axis. It's flipping down or flipping up across the x. I'm going to jump over to F because they look so similar and they're so confusing for students. This is reflecting across the y-axis. You're flipping left to right instead. And E is we are going to shift up 5 units, and G is we're going to shift to the right 5 units.